Question number 10 says, evaluate this particular integral from 0 to pi by 2, 2 log sin x minus log of sin 2x dx. Okay. Now, this particular integral is not very difficult to handle, but this integral looks something like one integral which I would like to share with you at one particular value. Basically, if you have integral 0 to pi by 2 log sin x dx, this is equal to what? This is equal to minus pi by 2 log 2. The value of this integral is equal to this. Not only this, you can have cos x also over here, because you can use the king property and say, okay, I can replace the sin x by sin pi by 2 minus x, which will be cos x. So log cos x dx will be minus pi by 2 log 2. As well as this log sin 2x can also be written in that particular form, but that's for another day. This particular integral has been solved in the NCERT, one of the examples, and should we remember this? Yes, we can remember this, right? So integral 0 to pi by 2 log of sin x dx is going to minus pi by 2 log 2. That's what you observe over here. Is that okay? Yes. What else? What else? So I've also mentioned that log cos x or log sin 2x, if that is also there, then the value will be minus pi by 2 log 2. What about this one? So I'll explain this question and let's see the important thing. Will we need that formula? Frankly speaking, we will not. But how will we attempt this one? Let's take a look at this. This integral is integral from 0 to pi by 2. This is 2 log sin x. Okay. And what is this? This is minus log of sin 2x. Okay. How will we handle this? Let's take a look at this. Minus, this is log of sin 2x is actually 2 sin x cos x, right? So can I write it as log of x into y is log x plus log y. So log of 2 into sin x into cos x will be log 2. There's a minus. This becomes minus log of sin x minus log of cos x. Can I write it as this? Take a look at this carefully. So I've written sin 2x as 2 sin x cos x. 2 sin x cos x. Where are these minus coming from? Because there is minus at the top. Otherwise, this would have been log 2 plus log sin x plus log cos x. This would have been das. But because of that extra minus, this is what you get. And bracket closed dx. This is what I see. Yes. Yes. What else? Okay, log sin x and 1 log sin x will get cancelled. This will become 0 to pi by 2 log sin x dx minus integral 0 to pi by 2 log 2 dx minus integral 0 to pi by 2. This term has been cancelled because of that, and what you get is log cos x dx. If you observe carefully, this here and this here are these exactly same. Yes. This is cos of pi by 2 minus x, which is actually sin x. So applying the king property, this and this will be equal. So they will get cancelled, right? And what we'll get is this. So let me write this in terms of cos x by applying the king property on this by P3. 0 to pi by 2. This becomes log of cos x dx. And once you see this, now we'll cancel that. This is log 2 over here, and integral of 0 to pi by 2 1 dx will be pi by 2. So you get pi by 2 minus, this is integral 0 to pi by 2 log of cos x dx. This is what you see, and this gets cancelled. The final value will be minus pi by 2 log 2 is what I get. That's my answer for this particular question, as you can see over here. Is that okay? Yes, that's all in this question.